I hit the button. Physics video. Really shouldn't be bothering. But there was some stuff floating in my head, and just figured we'll get to it. Wanted to do a more disciplined video, but this is all you're going to get for now. Very busy and such. Anyway, so this Jim Alcoholic guy, you know, who made a mess out of the two-slit experiment in a video I saw, or I did a video response to already. You know, he's still doing this, whatever, this quantum biology explains life. I mean, talking about wormholes and all of that mush inside of atoms, and it's just very depressing. But anyway, speaking of depressing, Hafade has left a comment, and you know, I don't know what to say. I'm trying to be as clear as possible, and I just don't know how there could be these kinds of misinterpretations or misunderstandings. So he says, are you now endorsing the idea of a field? Well, anyway, these videos I've been making have been consistent from the beginning. I've changed minor details as it's occurred to me, but the basic idea has been the same from the very beginning. There's no now endorsing crap. That is my impression here. So he's saying, I'm calling it a field because that's the word everybody uses to describe an electric field, a magnetic field, gravitational field. That's what people called it. Alright, now you want me to call it something else? Fine. I've said it as explicitly as possible. There's only one force in the sense of field. And that's gravity. Everything is a manifestation of gravity. Magnetism, electricity, all this stuff, all movement, all velocity, all everything is a manifestation of gravity. It's the only force. Directional exchange is the only event. It's the only mechanism. And it's just how deep or invisible it is to our eye perceptually, based on the fact that it's covered in zillions of interactions, that we see it differently. But what's happening is the same. The same thing's happening in the sun, the earth, a potato chip. All of these things are being held together and are doing what they do based on the implications of gravitational attraction. But what it really is gravity, directional pressure, pushing things together. Okay. So reality equals free quanta. So you got that right. That's right. Bunch of quanta, chaotic equal distribution of pressure. Constrained quanta, matter. Well, constrained is the wrong word. Captured in a consistent pattern. It's not just constrained, it's caught in circular motion. It is perpetually undirected. It is caged quanta. Might be a better word to say it. Constrained is, it just doesn't describe it completely enough, in my opinion. Coupled quanta, light. Coupled, I would say, is again the wrong word to use. The light isn't coupled. How to put it? There's no direct connection. There's no association between the photons at all. They know nothing about the association they've been forced into. They've just been given a number and gotten in line. And they don't know anything about, if I'm number 4, I don't know anything about number 3 or number 5. I've just been pushed into the line. So there's no coupling, and all there is a byproduct of frequency. That's something that is the whatever the word is for that stuff when it comes as a consequence. Anyway, and then he says, and a field? No. You just described the field. There's free moving quanta moving the speed of light. Some of it is captured in matter. some of it is moving at a frequency. That's it. There's a big giant pile of it that's neither matter or light. Okay? It's neither in the form of frequency, what's going on? Yeah, my power went out and I couldn't get the main breaker to flip back on. And I finally, with a pair of pliers, got, you know, the new $1,200 breakers, finally got it back to on. And but one of my circuits in the house now is dead. And it's like, you know, fuck. So I got no overhead lights. Anyway. Fucking electricians. Yeah, they don't understand any of this stuff. Anyway. So yeah, there's just directional arrows. There's just quanta. And the quanta could be in the form of an orbit, caught in an orbit, or it can be in the form of frequency associated, linear, same vectored emissions. But that, again, that's a tiny percentage of the overall field of what is potential energy, but it's only going to be seen as energy when there's a disproportion in its movement. Again, you don't, if a school of fish is just all swimming in chaotically and it's staying in one place, you don't see its energy. You only see its energy when they're all swimming in one direction, when there's an imbalance, when they all have the same identity. So when the arrows are all pointing in one direction because of some filter that's produced that effect, then you notice it as energy. But otherwise the energy is dead. It's always balanced by some counter energy that negates it, some counter direction. Alright. So another way to look at this is, so when you're looking at physics, I mean, the important thing to think, okay, so we start with this quantum, this little bit, and then we move on to these other atomic particles. So you could say electrons and protons, which are all orbiting things. Okay, they're not particles, they're things that have orbits. And then you have atoms, which again is a thing made out of these things, these orbiting things. These things with orbits of their own are in here orbiting. So it's like the Earth with its moon going around the sun, except, you know, I don't think there's, the idea of nucleus is a little less, and the atom might be the beginning of the idea of nucleus. And so you have the bits inside here that constitute what would be the parallel to the sun. And then you have this thing called compounds, and this is where it all just, this is the big irrelevancy. The universe could function without this whole branch of combining atoms is pretty much nothing. I mean, in terms of physics. It doesn't add, it's not like, it's not part of the evolution, okay, of the mechanism. So when you look at the big universe and you're going all the way to the small universe, this is the part, if you got rid of this, if you killed compounds, and you just said there was just elements, and atoms could group together like a big stream of gold or a big blob of carbon, but there was no compounds, the universe would look essentially the same. The plants would still orbit the sun and all this stuff would still happen. So the compound chemistry is just an aberration. It's just something happening, but it isn't anything critical to the evolution. It isn't anything to do with the progression of from small machine to big machine. And so then you have to jump over compounds and you just move to like whatever, meteorites, and then planetoids, you know, and you could go with then suns, and then you get into the more complex things like galaxies, solar systems, and then galaxies. But the point would be, I would make, is it's the way they're configured is the mechanism. There's different ways you can configure this force gravity. So what I'm saying is the force gravity is what's holding the galaxies together, and it's holding the solar system together, but it's also holding the atoms together and the atomic particles together, and then ultimately the quanta and their directional information is what is holding it all together. It's the pressure in that field, the quanta field of arrows going in all different directions at the speed of light. That mechanism is the mechanism that everything else is an extension of. Alright, now the mechanics is obviously going to be different at this big level than at this little level. Here you're going to start talking about spheres. I mean, solar systems are planier. You know, they do have a plane, you know, that they function in. And galaxies are likewise. But you do have the idea of a sphere created, you know, as far as we know. Certainly the idea of creating spheres is something that's obvious in the solar systems and in the universe, the big universe. Now, whether spheres exist on a small universe, I'd say it's questionable, and I'd say the mechanics get simpler, so it's less likely, because there's not enough elements, not enough pieces. And durability is the key issue to all of this stuff. It has to somehow be able to survive in this chaos where it just doesn't get pulled apart. You know, it can get, it can wobble, but it doesn't fall apart. Atoms wobble, but they don't fall down. They don't break apart. Alright. So I think that's one perceptual thing to be aware of, is that we're in a little strange little dirty line of the universe that doesn't really, chemistry is not the important function. I mean, it's not the mechanical function. It's just one of those, I can't remember the damn word. People are always using that, they're always using that word, and, you know, it's for consciousness and stuff. It's a blah 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 property, a blank property, emerging, yeah, something like that. Anyway, boy, I mean, my vocabulary is getting so ain't what it used to be. So the point I wanted to make here, well, I wanted to make a few points, but I guess the one I'm going to remember first is, so I would argue that if you took this element, I mean, who knows what the universe was and how the Big Bang happened and what stuff already existed before the Big Bang exploded, how consistent the plasma was, all these kind of arguments. But you're just saying the quanta, the basic element, let's say that theory is correct, and that somehow matter has to be consolidated out of that. Now, the simplest form of consolidation would be the idea of two things moving, and they move close enough to each other, and then this idea of this directional thing happens. So there's a kinetic ball thing. So the kinetic ball hits this ball, which moves this one closer to this one, so to speak, and this one leaves this way. So we have an out here, so we have an in consumed. So in a sense it's consumed because it's going to stay inside this piece of matter, and we have an out which is going that way. But anyway, so this gets pushed in one. Okay, so now this has a velocity going down, but it will randomly be hit by something going this way, let's say, so then it'll go over here. And that's the idea of creating your first orbit, is that they have to be hit to create like a square. You know, stupid. So, you know, something just, you can imagine that just something has to be hit, you know, opportunistically. The right things hit it at the right order, and it moves in a square pattern. Oh, wonderful. It's just been one of those days. A choke. Alright, well anyway, so the two things, you can just imagine we get caught up in this pattern because there's a probability of them keep consuming one of these pressure arrows from the external world that keeps knocking their velocity in some other direction into an internal direction. So in the solar system, the idea would be, you know, that this these things are made of things that keep wanting to go straight. Alright, so there's all this kind of thing happening, and what's happening is that they're getting knocked down by the gravity, by the external pressure that they will consume, that pushes them in. So it converts directionality in one direction for directionality in another direction. And so it ends up exuding exactly what it consumes if you take it for a full cycle. But the trick would be, is like, this is a very flat thing, like a solar system. So if you were to look at a solar system from the two broadest perspectives, you end up with something, you know, very big, like a big source of light. Okay, here's the sun in the center. And so, yes, the gravity here at the center is going to be strong, but this gravity is all very weak, you know, from its whole, but by per square inch, this is going to produce much less gravity than if you take a view of it from the side, because then you have the strong sun in the center, and then you also have all these other planets in this plane. So if you were coming at these two things, if you're coming at this from the solar system from the top, its gravity is a lot less significant than if you're coming at it from the plane that it's orbiting in. So what I would argue that's happening with these subatomic particles is that they're not spheres. You know, they're not, I don't know, I guess I'll have to learn how to properly draw a sphere so give people the idea of a sphere. It's like a pumpkin, a ratty pumpkin, not very spherical. That's a little better maybe. Anyway, and something that's just a circular or flat orbit. You know, those are very different things. So a flat orbiting system is very different than a sphere. And so what parts of this atom are complex enough to be spheres, and what parts are still in solar system shape, would be significant, in the sense that now you can sort of understand that this is a kind of polarization, in the sense that the gravity is stronger from one angle than it is from another angle. The amount of blockage per square, yeah, what you're going to get out of it in terms of how much pressure is going to be created between you and it, how much negative pressure will exist because of the absence of directional information in one direction. Alright, and so another thing to understand is that the other thing about consuming gravity, this up and down direction, is that none of it's really consumed. You know, what's blocked in a direction that's not gravitationally active, in the sense that there's nothing being changed. It's just randomly moving up a little, moving down a little, moving up a little, moving down a little. Where these bodies have to be perpetually, they're perpetually consuming gravity in all directions, you know, through their velocity. But they're actually, you know, consuming it in the sense that they're producing arrows that will always be in the same plane as the orbit. So they're always producing direction only in the plane of their orbit. Alright, so that's another way of saying that. Probabilistically. Okay, so where do I want to go with this? So, yeah, so that's the thing about understanding the electron. So I want to get to, like, so what's orienting electrons, you know, around structure. It's a little different than just a magnet, because in a sense an electron is a kind of monopole. Even though they don't exist in matter, the subatomic particles are clearly kind of monopolish. The proton has a positive charge, the electron is known to have a negative charge, and the neutron is this neutral charge. Now that might be incorrect in the sense that the neutral might not be a neutral, it might just be a first negative and then second negative, or something like that. But anyway, that part doesn't matter. Less positive, and then something else can be even less positive, something like that. So how do I want to? So to understand, so that just might be a representation of orientation, depending on how something orients to something else. So the argument I would make is that when gravity is coming at you, it's not coming at you evenly. It has these tidal forces, so to speak, based on, like if I came at the solar system on its plane, Saturn and Jupiter might both be on one side of the solar system, and they're very heavy. And so there would tend to be more gravity on that side than on the other side. And so I would tend to start twisting in that inconsistent gravity. And it's that twisting, that orientation that you're going to have as you're in proximity to something. So that's what people should understand is that these atoms are simple machines, and their gravity isn't consistent. So it's kind of like a neutron star, where you have this situation of two stars orbiting each other. And what's happening is that the light from the stars is blinking. But what's also blinking, in a sense, is the strength of the gravity. When the two are lined up, the gravity here would be very strong. When the two are parallel, the gravity here would be weaker, because the total distance would be longer. And it's that whole inverse square rule. More distance, less force effect. And so in a sense their gravity is tidal. It's fluctuating. And so that's what's happening with atoms. Their gravity is fluctuating. So when they talk about wormhole, what they're really talking about is that there's this system, and let's say 90% of the time it has 100 gravity points, and 1% of the time it has 0. So 1% of the time it's not throwing anything out. And so it's almost like a knife swinging back and forth in the video games or something, and you have to time it so you go through when there's no knife. So there's 2% of the time where there's no knife, and you just have to go through when in that 2% to get through. And that's all a wormhole basically represents, is just that it's not that necessarily something is overcoming a pressure. It's that sometimes it is. Sometimes it comes in with enough velocity to just break down the barrier. But sometimes it just has the right time. So it gets through in the right time. How to explain that further? So anyway, so material structures are very complex. There's very rigid rules about alignments and all this stuff. So all these things have to line up. And they're all been moving by these tidal gravities. And that change their arrangement, and the electrons floating around matter are obeying those same rules, and that's what's creating the diffraction patterns in two slit experiments, is that it's a rule of the alignment of the charged particles that are inevitably collect around any material body, but don't get pulled in. So that's the catch. They're gravitationally attracted, but they're magnetically repulsed from each other. And I can't get into magnetism now, can I? No, that's too much. Because repulsed is a bad word to use. It just means that the pressure inside ends up being greater than the pressure outside, but it's technically still pressure. You're just filtering pressure again. Alright. Let me see where I wanted to do. Anything else I need to do with this? But I mean, the key thing to get into is how do you form? What's the, again, it's about this durability. So I would argue that when you're making this simple system, if I just had 4 things orbiting each other, and let's say the time it takes, the gravity between them, this gravity field, I mean, this, as these things are all moving, okay, they're getting pushed in by this pressure external. That's this consistent pressure. But any one time they can be moving out here, over here, backwards, in here. But the argument is probabilistically they're going to end up moving in this circle eventually. So even though they're going around the circle, something like that, the idea is their net, what they end up doing in net is staying in that circle. They have an average that they stay within. And the laws of probability are that there's not enough noise in the free external world to create a circumstance where this gets so far out that it can never be pulled back in again. And so that's a point where you reach this durability. And so with greater size you become more and more durable in some sense. More components, these systems become more and more durable to fluctuation and less likely to just fall apart or break down in terms of the equalizing. I see, I mean, obviously this thing would create gravity that would end up showing up over here eventually, and so something over here would get an extra arrow pushing in because this one blocked an arrow pushing in. So when this one comes in here, this direction goes out, this direction stays in the matter. So that's the idea, is just to understand that when something's doing this, there's something being expelled and then there's something being collected, and so there's a new direction being collected, okay, but this expulsion isn't necessary from the entire matter. It's just an expulsion into the neighboring atom, perhaps. So that's how the idea of it ends up being, the integrity of it ends up being maintained. And that's likely also why it ends up that the matter ends up with one charge on one side, and another charge on the other side. It's because of this tendency. I don't want to get into velocity and movement and all that stuff, but it's the consumption of those extra arrows that is producing the capacity to produce more arrows in a direction. So it's like, I was thinking about rocket fuel. So I mean, the idea of rocket fuel, and the idea that it's going to produce all this direction, out one end of the rocket. And what's basically got to happen is somewhere it's taking all of these all of this directional information, and somehow it's converting it to releases all in one direction. So it's releasing all of the orbits. It's breaking down the orbits all in the same position. So they're all it's like the atom breaks down when everything's going in the right direction, which is this one direction. It's being funneled anyway, and that's all kind of complex, because you have to create the pressure, and you have to have the container, and you have to have the nozzle, and you have to have all these instruments that will force the chemistry to release the arrows all in the same vector. And the consequence will be that when you release all these arrows going this way back into the universe, that you'll end up having to retain a bunch of arrows going this way, and that's why you'll move that way, is because you released a bunch of arrows going that way. So you're exchanging just arrows going, you're exchanging the arrows going up, keeping them, and you're getting rid of arrows going down. Basically. So anyway, I think I answered half of this question anyway. But yeah, so the real key is going to be doing some mathematics about what's your minimum number of these things orbiting. How many do you have to have? So I was also thinking about black holes. And what black holes might be is one of those, one of those things that releases the cosmic ray emission thingies, the laser beam kind of things or whatever. But you could have say you have a sun. I mean, I would argue the sun starts burning because as you get to the center, there's low gravity. So the thickest part of the sun, the gravity can't, it starts to get weaker and weaker. And so there's so little of these arrows now getting through that there's not enough arrows to keep the atoms together. See, so because gravity is a nuclear force, not a material force. So it's getting blocked as it goes through this heavy mass. Less and less of it is getting to the atoms in the center. So the atoms in the center are in a low pressure and they just start to break apart. And so then you have a bunch of photons flying out because the atoms are falling apart. And then they make all kinds of a mess because they have to go through the matter to get out. And so they create heat and all this other stuff. But I mean, that's why the sun's burning, is because when something gains enough mass, it creates too low a pressure in its core, and the atoms start to fall apart in the core. And so I was thinking about that and saying, yeah, so why don't black holes burn? Well, black holes are really kind of a whole skeptical. I mean, there's lots of reasons to be blah, blah, blah about black holes. But I was thinking if they novaed in a particular way. So if they novaed where, like, this section of it blew out. So it's like one of those laser beam supernovas that I've heard about. You know, where the thing blows up, the two poles blow out. You'd end up with a ring, like a Saturn ring. So you'd have a ring of matter now. So you'd just have blown out the center. You got rid of the matter in here. And this is your mass now. And this thing could keep collecting mass because there wouldn't be any, there wouldn't be any matter in the center to be denied pressure. So the low pressure in the center wouldn't matter, theoretically, because there's no matter that needs to be held together. Just quiet space in there, right? And that kind of happens with electricity, like I've said before. That's, you can have very high currents on these outside and you'll have nothing in here. And the same thing is true with gravity. There's no gravity in here. And that's what I'm basically saying is the whole problem. There's literally no gravity. I mean, not enough. But like I said, it doesn't matter if you just make a donut. If you make something hollow, or you make a donut, then you can get very heavy and you won't catch fire. So black holes might just be donuts, or they might be spheres that have a hollow center because it blew out. Right. I think that is all theoretically possible. Mechanically possible. So anyway, that's one of the key things to this physics thing. So like I said, see, this is theoretically a possibility as an orbiting system, without having any center, no sun. You could have a solar system with no sun because the gravity between these different points would be enough to keep these things together. But it has to be even more precise in terms of the timing for something like that to hold together. But it's theoretically possible, and the neutron star is sort of an example of it too. There's no center thing. They're orbiting about. They're just orbiting about each other. But making one of those durable is the trick, and you can kind of see that in decay. Decay of atomic particles might have something to do with things that lose nucleuses and then they decay. But anyway, that's a whole nother. Don't want to get there. So anyway, that's enough of a video. I think I just made the points I needed to make. The perceptual point, I think its key is just that we happen to be part of that compound structure, elemental compounds, and it's just a weird little niche in the universe, and the real universe is kind of displayed by the the circular dynamics of everything smaller than a compound and the circular dynamics of everything bigger than a compound, if you get me. A meteorite going to an atom, and we're this thing in between, this blob, but it's not a necessary in-between part. Is as necessary. We're in between atom and boulder, atom and rock. We're just a form of rock, and materially. So, yeah, so that's about all I need to say. But everything in the real universe, where there's empty space surrounding it, see, we're always living in a sea of chemistry. So we just have a fake perception of reality because we're not floating in space and we're not being affected by space functions, where the atom lives in space and the meteoritic little rock floating in space is living in space. We're just out of space. We're inside compound chemistry. We're in a sea of chemistry. So we're just not, we just don't relate very well to the real universe, which is floating around in the same empty space. The empty space around an atom is exactly the same empty space around a sun. They're the things being affected by the real force, gravity. Alright, that really should be enough. Sorry, a bit of a ramble. But I'll have to do.